So I am Chris Smith. I work on a consensus spoke named Meridio. I'm one of the tech leads there, focusing mostly on smart contract development and API development. And throughout this presentation, we're going to go through some code, talk about some tests, go through some preferences that I have when writing tests for smart contracts. If you can't hear anything that I say, if I start talking too quickly, if you have any questions, raise your hand, interrupt me. We can make this interactive. Really kind of want it to be like a code. I probably won't do any live coding, but make it an interactive session, kind of somewhat of a workshop format. So Meridio, we should tell you a little bit about what we're doing. We are doing security tokens on blockchain representing real estate and investments. So we're trying to make investing in real estate a little bit less onerous, a little bit easier, maybe a little bit less requiring trust and third parties and intermediaries. And so we are building off of ERC20 smart contracts to build encoded compliant security tokens. Our kind of two primary focuses are building those security tokens and then also building a platform that abstracts blockchain away from users as much as possible. Real estate types are notoriously slow to adopt new technology. I think they've recently upgraded to Excel spreadsheets. So we're trying to ease them into this new wonderful technology that can really help them. So for this talk, we're going to be talking about smart contract testing, Truffle testing strategies. Like most of the developers that I know, like probably all of you here, I use Truffle as my test suite, as my local framework to run my tests, to manage them. A lot of the tutorials online are focused. I should probably advance my slides. So sorry, this is Meridio. This is, if you want to find out more about us, meridio.co is where you go for that. So testing, why would you do it? It's good for your health. It'll help you sleep not at night if you're launching contracts on mainnet. If you're anything like me, knowing that they're well tested actually lets you sleep at night a little bit better. It helps you identify bugs and vulnerabilities in your code, manage Solidity upgrades. So when we move to version 05 of the Solidity compiler, I'm going to be able to run my tests and see what fails. Helps me debug while I'm writing the contracts. So, I tend to, like, if I'm writing in JavaScript and there's something going wrong in my code, I'll drop the console log and see what's going on, what the state of things are. We don't have those sorts of tools in Solidity, so I use tests sometimes to do that. Understanding upgradability patterns, I wrote a lot of tests kind of working myself through what's happening. And it can also provide some pseudo documentation for your contracts. Did you have a question? I thought I saw you raise your hand. Okay, cool. So some of the patterns that I've seen with testing, I want to go through a very simple repo that is built off of a challenge that we had at Meridio, where we're trying to build a token that only allows up to a certain number of investors to hold that token. So we're going to set a cap on the number of holders or investors on this token. So we have OpenZeppelin's standard token here that we're inheriting. Basic setup. The main difference here is that we have this validator that we're going to set in the constructor. And that validator is going to be another contract that we'll look at in a second. We're going to call that contract before we do a transfer. And if this validate function doesn't return true, then we're going to fail here before we call the inherited transfer function. So what does cap validator do for us? Pretty straightforward contract. We're going to set up a cap for testing demonstration purposes. We're only going to allow 3 investors. We want to start out with an investor count of 1 because in our token constructor, we're sending the initial supply to the owner of this token. So the person who creates this is going to get it, which means that we need to have an initial investor count of 1 here. And then our validate function takes the from balance, the to balance, and the amount, and checks some kind of complicated logic here to see if we are adding a new investor. So if this is new and the person sending tokens is not leading, then we want to add to our, well, first we want to check to make sure that we're not going to go above our cap. And if we do, we're going to return false, and that will trigger the require statement and throw and revert the transaction. If not, then we're going to add a new investor to our investor count and return true, allowing the transaction to go through. If it's not a new investor, but the person sending the tokens is setting their balance to 0 after this transfer, then we want to account for that as well and subtract 1 from our investor count.
Why have the validator be a separate contract?
So in this example, I probably wouldn't if I was building this specifically. For our ecosystem, we're having multiple validators. So we have the investor cap validator. We might have a whitelist validator where your address has to be on the whitelist before we can transfer to you, proving that we've done KYC. So each of those validators acts as a module on our token, and being able to add them provides some value. It also allows us to reuse this contract. So we've heard about different upgradability patterns today in some of the other presentations. One way, without kind of getting into delegated calls and proxies and all of that stuff, we can add modules that allows us to change some of the logic of how our contract works. So we can launch this cap validator, use it on multiple tokens, and if we need to change it, need to upgrade the logic of how our cap validation works, we can launch a new one and point those tokens to the new contract. So our contracts, our basic contracts are set up. We also have a migration here where we deploy these contracts. And so we have to deploy the cap validator first. And then once it's deployed, we're going to set the cap validator address in the constructor of our simple token. So this is our test. It covers all of the expected functionality of simple token and cap validator. Should assign the initial supply to the owner. It should initially have an investor count of 1. Should allow the owner to transfer to another address. Afterwards, it should have an investor count of 2. It should allow that other address to transfer to some third party, and then have an investor count of 3. And it should allow transferring to not new addresses. So that's we're just transferring between accounts that already hold tokens. And afterwards, it should still keep the same investor count. And then if we transfer to, or should not allow transferring to a new address if we're at the investor cap, so that's a critical one. And should allow a transfer of the full balance to another address, and then we should decrease our investor count. So each of these tests I have set up to use the deployed contracts from our migrations. And then in each, I'm referencing those instances of the contracts.
Can you go through like that first one, maybe line by line?
Sure. So before the whole contract, we're going to use the Truffle built-in deployer.deployed contract. So get the deployed cap validator, get the deployed simple token. We set the owner balance, so simple token.balance of. I'm using call here because it's not an actual transaction that I want to execute. That will give me the balance of the owner, or the address that I have set up here at the top, accounts 0, which by default is what Truffle migrations use when they launch the contract. So if we go back to our contract, we're in the constructor message.sender gets the initial supply. Oh, yeah.
Oh, sorry. Just finish it. Yeah. You can finish that. I had an unrelated question.
Okay. And so all we're doing in this first test is getting that balance. This is balance of is an ERC20 function that we've inherited through standard token, and then we're testing with the 2 number to make sure that it's the initial supply, which is hard coded in our contract. So I've hard coded it in the test here as well.
Oh yeah. So can you go back to simple token? So yeah, in 9.5 we have the dependency injection of the validator into this constructor.
Yeah.
So if we change the validator, we had to redeploy simple token.
Yes. So in this instance, we don't have the functionality to change the validator on the token. We'd have to redeploy it, which would be problematic for the upgradability stuff that I talked about over here. For like the contracts that we're using in the ecosystem, there are add and remove module functions that keep track and remove the validators.
Okay.
Yeah, so I kind of artificially created these contracts
Yeah.
for this presentation to show some of the interactions and try to simplify some of it so I didn't have to get into the, I think my current test suite's around 400 tests,
Yeah.
so that was a little much for a presentation. So this first test is fairly small. First couple tests, actually. I want to look at this one as well. So here we're actually doing a transfer. We set an amount. It's just, I think, clearer to have that amount as a variable up here. And then the owner transfers to our second address, Alice. Then we want to check that the owner balance is initial supply minus amount, and that Alice's balance is now amount. And then after that, we check that our investor count is now 2. So this shows one of the things that I personally dislike about many of the tutorials and examples of testing that I see. These tests are all related to each other. They share a state. So as each test runs, we do a transfer here, and I'm setting this owner balance in the Mocha JavaScript describe blocks object and storing that, because that's what's happening on chain. That owner balance is the same throughout the rest of the tests unless I change it again. And same thing with investor count. So you can see here, this investor count test doesn't transfer anything. It's inheriting the state of the contract from the test above it, which means if I ever have to write a new test or refactor these tests, the order is extremely important. The sequence is extremely important. What if I write a test in here that, I come back 2 months from now and say, well, I want to make sure Alice can still transfer tokens away on line 37, and I put that in, Alice transfers all of her tokens. Now my test suite is breaking for no reason other than my tests were brittle and didn't allow for that flexibility. So we're going to look at ways that I get around doing that. But before we do, I also want to show another pattern. That's not it. Should not allow testing or transfer to a new address if we're at the investor cap. So through managing state of our contracts, we have reached a point where we have investor count of 0 or of 3, which means we have no remaining investor slots. So this test is testing the critical functionality of these contracts. There are no more allowed transfers to new addresses. So we try to transfer something, we put that in a try-catch block. We catch the error if it throws, and we assert true. This should throw an error. So if this throws an error, we end up in here, this assertion is true, and our tests pass. So these tests, as I said, do all pass. We've got Ganache running in the background, I hope, unless I turn that off. No, here we go. So, great. They're all passing, but we've already seen that there are some problems with our tests. The first one I want to point out is actually with this failing test assertion. So there are a couple of problems here that I wrote this test to include, to show, because I feel like I've seen this in a couple of tutorials online and a couple of code reviews. So problem number 1 is if this test doesn't fail, if the transfer doesn't fail, it will still succeed. So if I change investor cap to 4, that test will still be one of the ones that succeeds. The other ones will fail because my investor counts aren't going to, or my investor cap isn't going to match up. But you can see here, the part of this that failed is actually this line where I did assert that the investor cap is equal to the investor count, which it's not right now. If I turn that off, then we should see what I wanted to show.
So you have your shell showing you failed text, right? The red at the bottom, but it says non-failed.
So that's Zetius. It's actually showing me that the previous shell command returns something other than 0, I believe. Because that'll also, like, if I do my git log and look at my git commit history and then I hit Q, then I also get that. Actually, no, the green check mark. I've seen it on other things where I like Control C out of things. It just shows up the shell command.
So that's not a special Truffle thing.
It's not a special trouble. No. So at this point in our history, or in our test, we have an investor count of 3 and investor cap of 4, but our test proving that we can't transfer is still passing. Because we never entered this catch here, but if you just write an empty test in Mocha, that test will pass. It doesn't automatically fail tests. So if it doesn't throw during a test, then Mocha believes the test passes. So those tests will pass, which is where this sort of failure testing becomes really important for how are you catching these. So there are a couple of ways that you can do this. One is you can say assert fail here, and then inside the catch return. And that would cause this test to fail if transfer succeeds. And another way that I've seen it is by moving that up there, because if this fails, then we automatically jump into the catch block. If it doesn't fail, then we go to assert fail here and get kicked out of the test with a failure, which is what we want.
Oh, with the search fail, are you able to do custom messaging with that as well too?
You are, yeah.
Yeah.
I thought you were able to. So assert fail is actually something that I don't use very often. I usually do this. Assert is true, and then automatically put it as false. There's another problem with this pattern as I've written it here. This doesn't actually test only that transfer failed. It tests that we had a JavaScript with row somewhere in here. So if I just do something as simple as console log my var, because my variable is not defined, I will get a throw there, and that test will look like it has passed. And so we have passing test suite again, yet our functionality is not right. So the way to fix that is in your test to assert is true error to string dot contains revert, and that should cause that test to fail. Checking that the error message the catch block receives contains the word revert. Since we're looking for a transfer failure in our smart contract, then that will So this is how I usually write that assertion. Error to string includes revert, otherwise throw or show an error saying that it didn't throw, and then I find it helpful to include the error message that I received so I can figure out where in my code I have a problem. So that's how I like to solve my reverts and do that. There are a couple of utilities that you can use. One of them is in the OpenZeppelin library in the NPM package for OpenZeppelin Solidity. So you saw that here I'm inheriting their contracts, but you can also pull in their helper utilities. So in their package, they include their tests, which also have helpers. And so if you pull in and include this assert revert function, then you don't have to actually worry about this and rewriting it over and over and over again in your code. You can use theirs and check that there is a reversion. I personally use one that I've kind of built over time that kind of checks whether or not a contract didn't deploy or checks other types of error messages. But OpenZeppelin has a good one that you can pull in on any projects. If you're already using that package, it's a great thing. They also have a lot of other good test helping functions in here. Some of them that I've used involve controlling block time. So you can increase time. Here's another test, expect throw. You can expect an event. And so these are really helpful when you're looking at writing your own tests, what sort of utilities you can bring in. I would definitely recommend checking out their helpers thing. And if you want examples of tests, they have a good library of tests in here as well, especially if you're using one of their contracts. They probably have a test that's similar to the one that you need to write. So we've solved the testing revert issue, but the bigger pattern that I want to fix is this state management between tests. So we have access when we run Truffle tests to the contracts that are deployed in our migrations. I have two concerns with this when writing smart contracts. One, as we talked about, is managing state between my tests and how that creates a brittle test suite. Two is I have seen it lead to writing migrations specifically for the purpose of testing, which then means when you want to deploy your contracts onto a testnet or onto mainnet and you run your Truffle migrations, you could be deploying contracts that you don't need to deploy to main Ethereum network because you needed them to test. So one of our contracts, or one of the tests that we had in our suite used this pattern, and so we had to deploy these two test tokens. And when we got to the point of deploying to mainnet, or deploying to Rinkeby, we didn't go to mainnet, but we got to the point of deploying to Rinkeby, we had to pull those out and remove those migrations that those didn't go through. So personally, I don't like mixing the migrations with my test requirements, and also, like I said, it gives me that brittle state. So the pattern that I prefer to use when writing this is to encapsulate my tests.
I like that power line.
Thank you. It's Z-shish.
Oh, okay.
I'm sorry. So instead of using deployer.deploy and getting the deployed contracts from my migrations, I deploy a new contract